All right, welcome here. 5.2, day number 2. We're going to do examples 5 through 7. We're going to continue to verify equations using trig identities. This time we have a fraction, and we want to eliminate the fraction first. So I'm going to multiply top and bottom by 1 plus sine over x, 1 plus sine over x. It's kind of like the concept of complex conjugate, but not exactly the same. When I do that, I'll go ahead and come out here. It makes cosine x plus cosine x sine x over 1 minus sine squared x. And one thing that does for us is it gives us a sine squared, and we know we can convert that to cosine squared x here in just a second. On the top, common factor is cosine of x, and so it'll be 1 plus sine of x. So I factored out cosine x on the top. On the bottom, use the concept that sine squared plus cosine squared equals 1. Subtract sine squared from both sides. And so 1 minus sine squared is what we have over here, is equal to cosine squared of x. Okay. Well, now I notice that I can cancel this out. This is actually cosine to the first of x. And so it's going to cancel one of the cosines on the bottom. So that's going to leave me with 1 plus the sine of x over the cosine of x, because this is kind of like x over x squared, and one of them's going to cancel. Okay, I'm going to break this apart into two fractions, meaning 1 over cosine of x plus sine of x over cosine of x. And I know this is good because if I add these two fractions together, I end up with a fraction on the left, so I know it's an okay thing to do. 1 over cosine, we know that is secant of x. Sine over cosine, we know that is tangent of x. And that is the original problem. And since I've just made the right side look like the left side, I know I'm finished. Go ahead and see if you guys can figure out number 55. Press pause, work on it, try to work it out. If you get stuck or just want to check your answer, come back and press play and see what I did. Okay? Well, what I notice here is, with 1 plus cosine of x, the best thing to do is multiply top and bottom by 1 minus cosine of x, just to get rid of that. And that's going to leave you with 1 minus cosine squared x on top. And on the bottom, I'm not going to do distributive property this time. I'm going to leave it like that. 1 minus cosine squared of x is the same thing as sine squared of x over sine times 1 minus cosine of x. Okay, work our way down. Sine squared is going to cancel out the sine, leaving sine x on top and 1 minus cosine x on the bottom. Just like the last problem, I'm going to break it into two fractions, sine x over 1 minus, well, no, actually I'm not going to do that anymore because I don't have to. That is the match. I'm done. Good job. Move on to example 6 now. In example 6, this one says to work on each side separately. Without those directions, what would tell me to work on each side separately? Well, the first thing I notice is the idea that there is a fraction on both sides. So let's go ahead and work on these two sides independently of each other. Cotangent squared x is the same thing as cosecant squared x minus 1 over 1 plus cosecant of x. This will factor into cosecant of x plus 1, cosecant of x minus 1, because that is the difference of two squares. And I also knew that cotangent squared x equals this because it's on my formula reference sheet, over 1 plus cosecant x is also the same as cosecant of x plus 1. And notice those cancel out, and I'm given cosecant of x minus 1. Well, that seems to be pretty simplified. Let's see if I can make it into the same over here on the right, into the same thing. Well, on the right, I'm going to break this into two fractions, 1 over sine of x minus sine of x over sine of x. Well, that looks pretty convenient. 1 over sine is the cosecant of x. Sine over sine is 1. Voila. I've made the two sides match each other. That's how you do it. See if you guys can figure out number 57. A little more challenging, I agree. And I'll tell you now before you press pause, this right here, use the pattern a minus b times a squared plus ab plus b squared. Use that pattern to try to figure it out. Okay? Press pause, see if you can work it. Okay, now we're back. In this situation, a is the tangent of x, b is 1. And if you don't recognize this pattern from Algebra 2, it's simply the difference of two cubes, which means I'm factoring a to the third minus b to the third, and this is the pattern it factors into. So this is going to be tangent of x minus 1, a squared, so it's going to be tangent squared of x, plus ab, so it's going to be plus 1 times tangent x, and then plus b squared, well 1 squared is 1, over tangent of x minus 1. That looks like an exponent, it's really not. Tangent of x minus 1's cancel out, leave you with tangent squared x plus tangent x plus 1, which is the same as the original problem. Therefore, I've verified it. Last example for this section, example 7. A little more challenging, but I know you guys are up for it. How can I make tangent fourth x into tangent squared x, secant squared x minus tangent squared x? That is the question. Well, I know that tangent to the fourth is the same thing as tangent squared x times tangent squared x, essentially saying x squared times x squared is x to the fourth. Same concept. I'm going to take out one of the tangent squared x's and leave the other. And the reason why is because this already has tangent squared x in it, so I know one of them has to stay. And I know by my identity that tangent squared x is the same thing as secant squared x minus 1. Now if I do the distributive property, that's going to leave me tangent squared x secant squared x minus tangent squared x. And I just verified it with that right there. Example B, same type of idea. Something long on the left equals something even longer on the right. Let's try to break this one down and make it look like the left. What I notice about the first two terms is common factor is cosine to the fourth of x. That'll be times 1 minus cosine squared of x, because 6 minus 4 gives me 2. And then sine of x. I kind of see where this is going. We've seen this one enough times. We should know that 1 minus cosine squared is the same thing as sine squared. And now I have sine squared times sine, which is sine to the third x. Apologize for the sloppiness of that exponent on the cosine. And now I've got the right side to look like the left side, just backwards, but same thing. There you go. Let's try one more of those. Example 7c. On example 7c, we're going to mess with the right side. What I notice about this is I'm going to actually factor out a cotangent from this, and so it's going to be cosecant squared x times cotangent of x times 1 plus cotangent squared of x. Factored out a cotangent of x from the right side. Next thing I notice is that cosecant squared x, 1 plus cotangent squared x is cosecant squared x. So I get cosecant squared x times cotangent of x, and that's times cosecant squared of x. And now I have cosecant squared, multiply those together, and get cosecant to the fourth x times cotangent of x, excuse me. Left looks like the right. I'm done. I've verified it. Last problem for you to try for your homework, number 69. Tangent to the fifth. Go ahead and press pause. See if you can figure this one out. Work on the right side this time. Alright, we're back. What I notice here is the common factor is tangent cubed. So if I take out tangent cubed of x, that'll be times secant squared x minus 1. Formula reference sheet says that secant squared x minus 1 is equal to the tangent squared of x. Tangent cubed times tangent squared gives me tangent to the fifth of x. Right looks like the left. Verified. Done. If you're looking for your homework assignment, you go to the assignment page. It's 5.2 day number 2 for this assignment. Okay? Thanks.